So we're going to quickly look mostly just at the answers for this worksheet and kind of how to set up each problem. Try and get through it so that you can find your answers quickly if you're just checking your work. Let's go ahead and get started here on the first one that we did in class. Pretty simple strategy here on the first one is that we have a displacement of 1925 miles, and in this displacement there are two different airplanes that fly towards each other and have two different displacements. First one is kind of shorter, the second one's kind of longer, and they will add up to 1925, and that's kind of critical in this problem. So we'll call those two different displacements or changes in position x1 and x2, and they're going to add up to 1925. We're going to use our equation from our lab, y equals mx plus b, for our change of position here. So our x final, that will be like this. It's going to be equal to our velocity times our time plus our x initial. We're going to ignore our x initials here, and so let's just plug it in. So x1 is equal to 225 miles per hour times the time that the two planes are traveling. We're going to say that the other plane is going to travel a different distance, a different displacement, x2, is equal to 325 miles per hour times the same time t. And we're going to take these two and we're going to add them together, because we know in the equation for distance, we know that we have x1, and if we add to x1 x2, then we should get 1925 miles. So as we make a substitution now, instead of x1 and x2, we put in 225 miles per hour like this. We'll put in 325 miles per hour also times t. And we'll say equals 1925. Since both these terms over here on the left-hand side of the problem have a t right here and right here, which add them up, and so we would get 550 t equals 1925. Okay, I'll jump back over here. So 550 t equals 1925. We divide both sides by 550. We find that t is 3.5 hours. Then we multiply it back into our two equations over here in red and in blue. And we're going to find that x1 is equal to 837.5 miles, I believe. And we're going to multiply back in and find that x2 is equal to, numbers escaping me. I'm going to correct that there, made a small mistake. This right here should be 787. And the next one is 1137. Okay, and that is the first problem set up and solved there. Let's go on to the next. boats. Okay, leaving at 2 different times. They're going in the same direction, and one will overtake the other. It's going a little faster. And we kind of modeled this kind of situation in class. So both boats are going to start at the same place, and they're both going to end up at the same place. Okay, some distance over here, we call x, and they're going to ask us how long, which is we're looking for time, and they're going to ask us what distance. So they want this x. The difference in these two boats is that one leaves 2 hours later than the other, so it doesn't need as much time. It has to go faster. Okay, so the V2, which is the velocity of the red boat, has to be higher than the velocity of V1. Put these on time, if you will. So we have 24 and 32 as our velocities. So let's go ahead and set this problem up. And write down our equations. We're going to say x, the distance that the first boat travels, has to be 24, times some amount of time. I don't need to put one there, it's only the same x. And then the other boat is going to travel the same exact distance, but it is going to go at a faster speed. And it does not travel as long. It travels for the same time t minus 3 hours, because it's going to leave 3 hours later. And then it'll catch up with it at some point in time. So we can see both these equations equal x right away. Since they equal x, we can set them equal to each other. Alright, so I'm going to distribute out my 32. It's 32 times t, and also 32 times 3, negative 3. Now I need to bring all my t's to one side of the equation, my number to the other side of the equation. So I will subtract 24 from both sides, 24t that is. I will also add in 96 to both sides. And that's going to leave me on the left-hand side with 96. And on the right-hand side with t. Okay, and we can divide both sides of the equation by 8. And we can find out that t is equal to 12. So that tells me how long each boat is going. Boat B is not going for 12 hours, because t is 12 hours. That's the first boat, the purple boat. So the second boat must be going for 9 hours. Okay, because that's t minus 3. All right, now I want to see how the distance the boats covered. And that's pretty simple, because I can take the equation right here. I can just multiply in 12 times 24. Okay, and I can also do the same thing in the next equation. I can do 9 times 32. And either one of those that I do, I'm going to get 288 miles, I believe. Okay, and that pretty much finishes up this problem. Let's go ahead and move on. Okay, let's take a look here. So we're going to have these two travelers that are going along the road in the same direction. And we are told here that one of them is going to overtake the other. Okay, in this first little instance here, we have traveler 1 with 15 miles an hour, traveler 2 with 24 miles an hour. These are velocities. We're told that one of them starts 2 hours after the other. So it's some kind of 2-hour differential. So x is again the distance they travel. They're going to have the exact same x, just like the previous problem, because one of them is overtaking the other. just say 15 miles an hour. That's again our velocity in the equation. And we'll multiply 10 times. We also have another equation for the motion of the second one. It leaves 2 hours later. Like this. Again, he left 2 hours later, or she left 2 hours later. So we have 2 hours less to catch up. Let's go ahead and set these two equal to each other, because they both equal x. So long as they both equal x, we can set them equal to each other. I'm going to distribute out my 24 times t and 24 times negative 2 as well. So in this equation here, I can bring my t's to the same side of the equation. Pretty simple subtraction of 15t on both sides. And also on the other side of the equation, I will add 48. And over here, I can add 48. And that's going to leave me with 48 on the left-hand side. And then it'll leave me with, on the right-hand side, so 9t. And we divide both sides. And it looks like about 5 1/3 hours equal to time. And that is the time traveled by the first one. Traveled by the second one would be 2 hours less, or 3 1/3. Okay, next problem. This one's a little harder because it's got variables more than numbers. And at this point in the course, you're pretty comfortable using numbers for certain things, but not as much for variables. This is the ratio of the speeds is 4 to 5. That's weird. And so you might call v1 is equal to 4 times, so here you use 4x and 5x for the speeds. You use x for position, so I'm not too comfortable doing that. I will just call it 4b, and I'll call it 5b rather than x, because I like to use x for position. But these are just variables now. So you'd be calling a Bob. You call the variable 4 pizzas and 5 pizzas, or any variable you please. We also are told that the first one, that's v1, makes a detour of 10 miles. So when we get a distance, we have to add in 10 to that distance, because it's going to go 10 miles further. He or she wanted to take a longer route. And the second one has also something that's going to change. It takes 2 hours after the first one leaves. Okay, we know how to handle that. And it travels for 6 hours. It travels for 6 hours. That tells us that the second one travels for 6 hours. It says so explicitly. But if it left 2 hours later, I'll say time 2 equals 6 hours. That's going to tell us the time 1 is 8 hours. And also, as far as the displacement goes, I'm reading this given very carefully here. I see that we're going to have some kind of x plus 10, and x is how far they travel. Alright, looks like I have enough information now to sort this whole thing out. Because again, the number 5 here, 1 overtakes the other. So let's go ahead and jot down our equations. So the first one says x plus 10, that's how far it travels. And it's going to do that in its velocity times 8 hours. The second one's going to travel x, and it's going to do that at this velocity for 6 hours. Sorry if my b's like 6's there, but not. Alright, and now we want to know what are those speeds. Well, the first thing I want to do is I'm going to make a substitution of one equation into the other for x, because I can get rid of my x, and I don't need the x. I need speeds. I got to figure out what 4b and 5b are. Let's rewrite my equations now. 5b times 6 hours is equal to, I forgot the 10, forgive me. 4b times 8 hours. If I multiply this through, here I get 30b. You have to be careful not to combine with the 10. One has a b and one doesn't. On the other side, I'm going to get 32b. Now I can subtract 30 from both sides here. Okay, then we get that 10 is equal to 2b. Or we can obviously see if we divide by 2, since 2 and b are multiplied. Dividing is the opposite operation. And so 5 is equal to b. I'm almost finished. 5 equals b is not my answer. Again, I want to take this 4b and 5b. So if we multiply 4 times 5, we get 20. Multiply 5 times 5, we get 25. And those are my actual velocities, the speeds that I'm looking for. Okay. I'm making sure they're, at least they are miles an hour. So miles here, hours here. So 20 and 25 miles an hour. Let's move on. Alright, so on this next problem here, we see that we have a situation where a traveler goes out, comes back to the same starting place along the same road. Same road's important, so we know the x going out and the x coming back are the same x, the same displacement on this round trip. So let's scroll up a little bit, give ourselves some more room. And this first problem here says the average speed is 24 miles an hour on the way out and 36 on the way back. Again, we know the two x's have to be equal because we're going to travel out and back on the same road. So I'm going to write down my equation that x is equal to velocity times time. This is like the final position plus my x initial. And we try and plug in some numbers here. We're just going to say x is how far we travel. It's going to be 24 miles an hour times the time. I'm going to call this time 1 to take a trip outward. It says let T1 be the time for the outbound trip, and T2 be the time for the return trip. That gives you a hint a little bit to solve this. I also know that these two times together have to equal a total of 8, because 8 is for the whole round trip. Okay, I'm going to add in a plus 0 here, instead of start at 0. So our total change in position is just the x. Now once again, when we came back, we have the same x. So we're going to say x once again. Over here is going to be equal to a much faster speed, 36 miles per hour. Time is the time it took to come back, which is not the same time. You're going faster now on the same road. So T2 should be shorter than T1. Let's go ahead and set them equal to each other. Because they both equal x right here and here. So we can set them equal. Okay. T1. Just 32, 36. Oh, that's T2. Okay, now we're getting somewhere, but I still have one equation and two unknowns. The two unknowns that I have right here are T1 and T2. So I'm going to need another equation with the same two unknowns to solve this. So I'm going to use this fact up at the top of 8 hours for a round trip. I'm going to say T1 plus T2 equals 8. Okay. So I can take this and I can drop into it. Over here I can say obviously T1 is equal to 8 minus T2. And I can take this and make a substitution right there. So I'll write down 36, T2. As I distribute this out, 24 times 8, let's see, 192, hopefully that is correct, minus 24, T2, equals 36, T2. I'm going to move all those T's, they're all unknown. I'm going to move them all to the same side of the equation. Let's add 24 to both sides. 24T, that is. And now cancel out the negative 24T. So we do to the left, we got to do over here on the right. It's T2. 36 and 24 is 60. So we have an equation that says 192 is equal to 60 T2. Alright, so divide both sides by 60. 3 times 60 is 180. This remainder of 12, or 2/5, 0.4. So it looks like 3.4 hours is equal to T2. Didn't mess that up. I messed that up. The remainder of 12 out of 60 is actually 3.2, isn't it? I apologize. 3.2 hours. And that is the amount of time it takes to get back, which is what I asked us here for. Find the time for the return trip, and it says that T2 is the time for the return trip. So we finish the problem. Let's go on to the next one. Okay. After taking 3 hours to go out, a traveler comes back in 5 hours. We have 2 times. Total of 8 hours again, 3 and 5. And we're 28 miles per hour slow on the way back. Find the average speed, V1, on the way out. Okay, so here's V1 that we need to find on the way out. Okay, and V2 we know is 28 miles an hour slower than V1. Okay, we also know that the X's are still the same because we're going the same distance out and back on the same road. So we have V1 times 3 hours. We have V2, which is slower than V1. And that's going to go for 5 hours. All right. And over here I can write down the relationship that I can use to plug in and solve. Now they're both equal to X right here. So we can say 3 hours times V1 equals 5 hours times V2. But I can take this equality over here that I just wrote down, and I can plug it in for V2. Okay. So we get 3 hours times V1 equals 5 hours times V1 minus 20 miles an hour. We want to distribute 5 hours. So we get 5 hours V1. That looks like similar terms, 3 hours V1 on the other side. Minus 140. I'm doing that right, miles per hour. Alright, so let's get all of our terms back to the same side as we'd like them to be on. Let's take a look here. Looks like I want to subtract 3 hours of V1 from the left. I have to do that to the right. I also want to add 140 miles per hour to one side, but I'm going to have to add 140 miles per hour to the other side. Alright, now we can go ahead and rewrite the equation. So I have 140 miles per hour on the left. That's positive now, not negative. On the other side I have 2 hours V1. And we can divide by hours. I just noticed one more thing here. These hours are canceled these hours. So this unit, 140 would be actually miles. You divide it by 2 hours. And dividing again is 2 and be your multiplier. And that's how we get miles per hour. Our answer. So the hours should not have been divided. So we get 70 miles per hour equals V1. And that is the V1 is the speed on the way out, and that's what we're talking about. Next, we're done. Let's go on to our last one. Okay, and let's take a look here also. Alright, so we have two trains that are leaving at the same time and head in opposite directions. After 8 hours, they're 360 miles apart, and the faster train is 3 miles an hour less than twice that of the slower train. That's kind of complicated. So it's 3 miles an hour less than twice that of the slower train. So find the speed of each train. This is kind of like our Beth and Carissa problem way back, I think, in the example at the beginning, where we have a slow one and a fast one heading in different directions. They end up a certain distance apart after a certain 8 hours of time. Let's try down equations for each of the trains first. Okay, so x1, actually I'm going to sketch this really quickly. Like we did earlier, we have a slower train going one way, and then we're going to have a faster train going the other way. Alright, and they go for 8 hours. I don't have 8 dots, 8 sets of arrows there, but that's fine for now. Let's go ahead and jot down the equation for the slower train. Okay, and it's going to have a velocity v2, and it's going to go for 8 hours. And let's jot down an equation for the faster train. It's going to have a different displacement, and that's going to be equal to so V2 here, I use V2 because it says this is the slow train. Okay, I'm using V1 over here because my faster ones are right arrows, but it says V1 is the fast train. Right. Now we know something. We know that they're 360 miles apart after 8 hours. So I know x1 and x2 have to add up to 360. That is, if I was to take this entire distance right here, in between the two, there to there, I've got to get 360. Okay. So I'm going to add up my two x's, x1 and x2. Say 8 hours v2. And that was a mistake. And we're going to add to that. v1, and that should equal 360. I need one more relationship here to kind of figure this out and solve it. I still have one equation there. I still have two unknowns, v1 and v2. So what I'm going to do is somehow relate v1 and v2 with the really weird information that one train is going 3 miles an hour less than twice the speed of the slower train. That's kind of complicated. So the slower train, right here, says it's v2. Right? And so what they're trying to describe, thinking through it, is that v1, that's the fast train, is not going twice the speed of v2. Twice the speed of v2 minus 3. Right, miles per hour. That's the speeds and how they're related. So I can go ahead and I can drop in this equality right here with v1 and make a substitution. Let's do that and keep solving. I ran out of room here. Let's see. I'm going to drop my units for a moment, try and save some space. Okay. If I distribute out the 8, 8 times 2 is 16 there. So 8v2 plus 16v2 minus 24 is 360. 8 plus 16 is 24. And this 24 has to add to the other side. Okay. So I can get the unknowns by themselves. I will arrow over here, and I'm going to say that 24 to 2 is going to equal 384. Okay? And we divide both sides by 24. And we'll find the speed v2. Okay, and that is 16. So I'm going to give it v2 is equal to 16. I can now plug that back into this equation right here. And I can solve that v1 is equal to 2 times 16 minus 3. 2 times 16 is 32, minus 3 is 29. So v1 is 29 miles per hour. Alright, and there's my answers. Hopefully this helped you out if you're working through this on your own. If you were stumped on one, I want to check your answers on these. And I will see all of you in class soon, and have a wonderful day.